We're now on page 33, and there's one more piece that we need to look at regarding this normal distribution stuff. Take a moment and read the problem on the bottom of the page. This looks like it would be an empirical rule problem, but if we tried to use that empirical rule with 34, 34, 13.5, and all that stuff, we would see that 2 years wouldn't show up exactly on one of the tick marks, so we need some other way to deal with this. We need to see how we can use that table of values, table with the standard normal distribution, to find the percent of data for any of these normal distribution problems. Well, to deal with this, I'm going to fill in stuff on the top and work the problem on the bottom kind of at the same time. The first thing we're going to do to find the percent of data to the left or to the right or between things on any normal distribution is we're first going to sketch a normal distribution, and we're going to label our mean and any important data values. Sketch a normal distribution. When we do that, we will label the mean and the data values that were given to work with in that problem. The second thing we'll do is we'll shade the appropriate region. Shade the appropriate region. We're going to start by sketching a normal distribution. We're going to label the mean and any data values, and then we will shade the appropriate region. So back to that example on the bottom of the page, I'm going to draw a normal distribution. My mean is 2.4 years. I want to figure out the percent of computer owners who own a computer for less than 2 years before upgrading. Well, I'm going to put a tick mark over here at 2, and I want the percent of people who own it less than 2 years before upgrading, which means I'm going to be shading to the left of 2. Step number 3. I need to convert my data value or data values into z-scores. Convert your data value or values into z-scores. We want to figure out how many standard deviations away from the mean we are, and if we're above the mean or below the mean. And then we're going to rewrite our inequality in terms of z-scores. We are going to state the inequality. Remember that our formula for z-scores is our z-score is our data value minus the mean mu over the standard deviation sigma. So in the problem that I have over here, I'm going to convert 2 into a z-score of 2 minus 2.4 over 0.5. And I just need to find my calculator. Two minus 2.5 divided by 0.5 should give you a z-score of negative 0.8. So this problem is really finding the percent of data whose z-score is less than negative 0.8. Well, we know how to do that. This involves just using our standard normal table. We can use the standard normal table to find the percent of data whose z-score is less than negative 0.8, and then we're basically there. Step 5. We are going to use the standard normal table to find the percent of data, and we'll either just take the number straight from the table, or we will do that one minus the thing from the table, or we'll do one data value minus the other, just all the different calculations we previously looked at. So I just need to find a table over here. I need to find the percent of data whose z-score is less than negative 0.8. Well, I'm going to go look at my table. I think I'm going with 0.2119. So 0.2119, but I need to write that as a percent. So my final answer is 21.19%. What percent of people have, you can't see that, sorry, let me move up. 0.2119, I'm getting 21.19%. So what percent of people have used a computer for less than 2 years before they get a new one? About 21.19%. One more problem to take a look at. Read through the problem that you see on the top of the next page and try to draw your normal distribution. So my mean is 45, and I want to deal with people in the grocery store between 24 minutes and 54 minutes. So I want this shaded region over here. And I now need to go deal with some z-scores. So 24, I'm going to say z equals 24 minus 45 over 12, which gives me a z-score of negative 1.75. 54, my z-score is going to be 54 minus 45 over 12. So a z-score of 0.75, which means I want to find the percent of data whose z-score is between negative 1.75 and 0.75. By the way, you might see this in the homework where a couple of the z-scores don't have a nice terminating decimal and you'll have to do some rounding. Because of the way our table works, make sure you're always rounding to 2 decimal places with the z-score, so we can find the tenths and the hundredths, but nothing beyond that in our table. Well, now we're going to go to our table. We're going to find the percent of data to the left of 54, or to the left of that z-score of 0.75. According to the table, that should be 0.7734. I want to find then the percent of data to the left of 24, or the percent of data whose z-score is less than negative 0.75. And according to the table, that is 0.0401. We're going to get 0.7333, and that will give us 73.33%. That 73.33% of people will be in the grocery store between 24 minutes and 54 minutes. See if you can do letter B. And as you work through that, I'll get my work up here as well. So I'm looking for the percent of data whose z-value is greater than negative 0.5. Go to your table, and I know I need to do 1 minus what's in the table, so 1 minus 0.3085, 0.6915, which looks like 69.15%. I can predict that about 69.15% of all people will be in the grocery store for more than 39 minutes. And that's it.